Thank you. With this, so I was asking a very simple question that whether everything is fine. Introduction to AI is the right way of writing this. Has I written this correctly? No, it should be introduction to AI. Okay. But all of you said that it is correct. Okay. Why? Because you have applied your intelligence. Okay. You thought that, okay, I know that this is the context. So therefore, 2 should not be a number. It should be TO. By yourself, you have applied this. So this is what the intelligence is that you have applied. You have got the context and you have said that, okay, Chalta, this is fine. It's good. Understand? Try to understand that what is intelligence. It was wrong, but you told you applied something. What you applied, you think about that. And we can discuss about that. And by this, you understood that, okay, the things are fine. Okay, this is the introduction to AI, correct thing. Okay, so intelligence is a very important characteristic that actually humans, generally we say that human are intelligent. Okay, not other things are, other creatures are intelligent. We generally don't say that. So if humans are intelligent, so then computer can also be intelligent. We are going to talk about that. Okay. So let me first try to understand that what a computer is. All of you already know. But if I go and try and go to the search for the what is a computer and open the Wikipedia link, so I will be getting this information. Computer is a device that can be instructed to carry out sequence of arithmetic and logical operations in an automatic way via computer programming. So it essentially says that there is some computer program that automatically does what? Sequence of arithmetic and logical operations. Arithmetic and logical operations? Computers are meant to do what? Arithmetic and logical operations. Arithmetic and logical operation means arithmetic means what is 3 plus 5, what is 5 multiplied by 3, 1, 2, something like that. And logical operation means A and B, A or B, something like that. So this simple kind of such a device which can only perform this simple kind of operations. Can we think that it can be intelligent? If somebody can add, for example, this is a calculator can do all these things. Huh? So how can it be intelligent? Okay, I don't know that how to. Let's for a minute. Let's don't think that how to make it. Let's assume that somewhere I find out some device, some computer that is behaving smartly, okay, intelligently. Somewhere, let's assume that I find out a device that is behaving smartly. So where is the intelligence? Is the intelligence inside the computer, or is the intelligence inside the person who have written the code for that? Where is the intelligence? Can you tell me? If such a simple device, which can only do the arithmetic and logical operation, performs smartly, so where is the intelligence? Whether this intelligence is inside the machine or inside the programmer who have this intelligence? Can you write me? Looks like that the person who has actually written this program, who is actually the human, the programmer who is supposed to be human, intelligence is in him because he has made this system intelligent. Okay. So now you understand that something which can make the things intelligent is we are talking about. Okay. So if we think that computer is also intelligent, let's not talk about that, how to make that. We'll talk on this later. Right now, let us only think about, let's assume that the computer has a AI, intelligence. Okay, let's say the computer has an intelligence. So what it would do? What it would do? It would write a program. Yes or no? Yes or no? Yes. Okay. So what I was thinking that computer should have intelligence. If the computer has an intelligence, it would write program code so that this code can behave intelligently. Okay. So how it is possible? What are the things required to work code actually? So we need something, some labels. What do I mean by label? So you know that everything has a name. Okay. For example, I have a I'm very bad in driving, so I should show you that how bad I am in driving. So let's assume that this is a chair. Okay, so it is chair. It is kursi. In other language, I am not comfortable. So you can find out other names also. So what this particular thing is called doesn't make any sense. Okay, it doesn't make any difference if I say it's a kursi or chair or whatever or X Y Z. If I say anything, but in the real life they have labels. I know that what is it is called. So what are the things and what is their labels? It should know. Then only it can address them. Na? So computer to make the computer intelligent, I should provide the labels that what are the things and what is their labels in my domain. And then there should be some databases that person can sit on the label. Okay, these things are possible. Something many things which are actually I have a database that how chair can be used, how pen can be used, how other things can be used, what is their relationship. So there should be a database of the things how they are related. Then I should have some experience. Okay, experience means what? Experience means actually database says that what are the things possible. Okay, experience says that I should not do that. For example, okay. So, for example, if somebody is going, somebody is talking, Mr. A is talking with Mr. B. So you know that he should talk in a polite way. Okay? Who is telling you to talk in a polite way? You can talk in any way. Okay, if you are telling your things to him, so you can tell him, raise your voice and tell the same thing to him. But experience says, no, no, we should put the things in this particular way. Experience says that it regularizes our behavior. So what are the things possible? What are the things? How they are connected? And how should I put it into the right way? If all these things are there, then then I have a hope that I do something. I'm not talking about that particular part right now. Then I can do something so that there is some intelligence inside the system, and then the system will be able to write the code. Any questions on this? Am I making sense? Am I making sense? Yes. So essentially, we want from the intelligence what we want that computer should be able to write the program. All right. So now I'm going to tell you a very important thing. Okay. And this thing is this. So right now we have talked about that I have developed intelligence into the computer. And then if computer has an intelligence, so computer has an intelligence. Is it a human intelligence? Because we are very much less aware about the human intelligence, how the human intelligence comes. Something is innate. For example, when the child get a birth, at that time we don't teach him something, but he knows, he identifies his mother, and he knows that how to do certain things, how to cry. If he have some problem, he should cry so that these other people get see him, get attend him. So many things comes innate. So for example, it also happens with the animals that different kind of intelligence they have. So some innate things are there. After that, we based on the environment, based on the things, we learn many other things. Okay. So 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 this intelligence that is there inside the computer and intelligence that is there inside the humans, okay, they are different. Can you see this? Not because we okay. We are not very much expert on this, but I'm touching a very sensitive issue. Okay, so so what I wanted to tell that the intelligence which are inside the human is actually the intelligent, but intelligence which are the inside the computers, again it is not good. Okay, again it is now it is coming from something done by the humans some way. Yes or no? Yes or no? Whatever is coming inside the computer is coming because of the human. Okay, so I say it artificial. I say it artificial. So essentially, I say the artificial intelligence. Artificial intelligence means the intelligence inside the computer. If it has an intelligence inside the computer, it is artificial intelligence. So the name doesn't mean that there is something artificial. It is not artificial. because it is being manifested as an intelligence. Okay, system is manifesting the intelligence behavior. But I am telling it, I am calling it artificial intelligence because it is inside the machine. If any intelligence is that there inside the machine, I will call it artificial intelligence. Make sense? So now I have a precise question. What is the difference between intelligence and artificial intelligence? Can anybody please tell me? Can anybody please tell me? Difference between intelligence and artificial intelligence? Intelligence is the human intelligence. Artificial intelligence is the intelligence shown by the machines. Correct? Yeah, perfectly right. And now many people are giving computer brain created by human. Look, I just wanted to be, I just wanted to regularize your emotions. Okay, don't be overexcited. Okay, we are not creating brains inside the computers. Okay, we are doing something so that this, let me call it only something only because at the end it turns out to be a mathematical formula. Whatever we are going to do, even in the neural networks we are going to talk about now, the neural network is just a matrix multiplication. So at the end, it becomes the same thing. Okay, that a mathematical background. So ultimately, our task is to create something mathematical, not the brain. So we should take something, take it with the pinch of salt. That okay, we are doing something, and also you know that whatever intelligence we have actually developed into the system, that is only in the capacity of uh, say bounded applicability. So we cannot tell that we have achieved any general intelligence. So in this some scenario we are able to achieve that. For any specific problem we are able to achieve that. We try to see that how much we can generalize, but fully generalizable systems are actually still we are working on this, and they are very difficult to get. We're talking about that. Okay, all right. So any questions? So I'm not sure here that whether we have any person from the tech team available here. Is there anybody from the tech team? Our tech team, tech team. If possible, please switch on the possibility of my students to switch on their mics. Can you please do something on that? So there is a question, where does AI keeps learned experience if database is different entirely in this diagram? Okay, so you want to tell that if this database is different, then what would happen? This is what the question is. Yes. Is it your question, Abhishek? Where does AI keeps learn experience if database is different entirely into the where does experience is stored? Where does experience is stored? So Abhishek, I would come to all these points now. Why experience? What do you mean? We have to try to understand that particular part. So we would try to understand that particular later when the things would come. Okay. Right now, any question related to that? So experience actually what happens now? Experience actually is time. Experience is only time. So with the experience, what should happen? That your performance should improve. If I on the y-axis I say that performance, so on this side experience. So experience is actually the time. As the time progresses, a good system should have the better accuracy. Make sense, Abhishek? What about the syntax of the programming languages? All right. So again, syntax learning is means finding out the pattern. So let's assume that I don't do the computer and I supply various here in the levels. What are the levels? Let's say C level 32 only symbols are there. So I tell that these are the symbols such as INT, VOID, MN, IN, such as I give these things and then I give multiple programs to them. So it should try to it should try to actually find out the patterns into the system, and somehow it should actually generalize that particular pattern. So one way to do this thing that if I reduce the capability of somebody, so and I feed him more, so what would happen? He would try to find out a middle path so that with a lesser capability, he should be able to perform the task. And this is what the regulation is. Okay. Sir, what sort of assignment do we get into the course? So I think this is not the right time. At the later time, we can discuss about this. Okay. So can we talk about this concept? So is it clear? Okay. So all right. So we were talking about the intelligence. Okay. So intelligence actually. Um, so till now we had not talked about that what is intelligence. Okay. By intelligence, if you have an intelligence, you can write the program. So this is the one task. So what are the other things that actually we think that if somebody is doing, we say that actually he is intelligent? Are you able to understand the question? So by intelligence, what do we mean? If what task the person is doing, then I would say that he is intelligent. Okay. Question is that what is the task that somebody is doing, then I would say that he is an intelligent. Okay. So these tasks actually comes into three categories. One is the mundane task category, another is a formal task, and third is a expert task. So three kind of tasks actually we can categorize based on the things that what is the intelligence. So mundane tasks are those tasks, for example, daily routine tasks. Okay, for example, when in the morning you wake up, you go and you clean your teeth. Okay, so you brush your teeth. This is the intelligent task. When in the morning you wake up, you actually clean your room by applying the brooms. You put your bed into the right way. Okay, so you fold your things on the bed. So what happens that these things are intelligent tasks, but you don't think that they are intelligent tasks. For example, when I am telling NLP, when I'm telling something, you are listening this and you are understanding that what I'm telling. This is also intelligent task, but you are not thinking that you are applying any kind of intelligent task. So these category of tasks are called the mundane tasks. So why I say that they are intelligent tasks? You are not thinking that they are intelligent. So just think about this, that in the morning time, when I told you that in the morning you are having brush on your teeth. So maybe you will be using your right hand to do that. So you change your hand and you pick the toothbrush by the left hand. Try to apply the things. Definitely in a minutes you would be see the difference that you are not able to do that particular part. If you are applying a broom, so you know that if you want to develop a robot that can do the cleaning, now we don't have the very good cleaning robots. Humans are better in that. Definitely there is something you have to plan, that how to take these dust out, planning and applying different kind of things. It's not easy. It is an intelligent task. In the same way, NLP. So for example, if you are an English speaking person, you know that you can understand English well, but you may not understand French. But the French person understand French well, but not English, not Hindi, not Urdu. So if you change the languages, you'd be saying that it becomes very difficult. So it's an intelligent task to understand these things. NLP. Second task category of task is this. When you are doing those tasks, you will be thinking that I'm doing some intelligent task. For example, game playing. Okay. For example, when you are playing chess, at that time you think that you are applying. In this class, for example, attending class. When you are attending this class, you will be thinking that, okay, it's an intelligent thing. Okay, you are doing some intelligent behavior. So these category of tasks comes into the formal one. And then come the expert tasks. Expert tasks are those tasks where only experts do that particular task. For example, operations, okay, medical operations uh, are the architectural planning, okay, city planning, architectural planning. So you know that if somebody is architect, he would be only doing that building design. and medical operations. For example, doctor only can prescribe you what medicine you should take. So they here only liar can tell you that how to frame the court cases. So expert tasks are those categories where only specified peoples are going to do that. So all these things comes into what categories? All these things comes into the category of the intelligent task. So now you understand this. Do you have any question? No? Do you have any question? No? So now I have a question. So out of these three categories, let me call it A, B, and C. So do you think which one you think that is more difficult to achieve in terms of the AI? If I want to develop the AI for them, the intelligent task. If I want to develop the AI for them, which is the most difficult? A, B, C, C. Many other people are telling C. Some of the people are telling A also. Okay. Okay. So the right answer is actually A. So right answer is actually A. Why? So you may have heard about that the robot are able to perform the robotic operations. Okay. So robot and now we have the software. If you provide that, this is what the land photograph is, land things are there. So they can plan that in which way the building can be made. Okay. So expert task looks like that the expert tasks are more easy to develop as an AI. My question was in terms of the AI, which was more easy to develop. Looks like that these things are more structured. Okay. Here you go into the structural way. And when the things have a defined structure, it becomes easy to do that. So in terms of the difficulty in developing AI systems, so most difficult is the mundane one. Okay. So developing a automatic robot that can do the cleaning is actually still not possible in a very good way. Okay, so somebody is telling that because we have rules for the expert task. So instead of rule, I can say that they are more structured. Okay, they are more structured. So we can find out rules easily for them. Here also we need the rules, but number of rules may be very high. Okay, so this is the thing that most difficult one is the expert task. Any questions on that? Are you convinced? Yes or no? All right. So there is a task, there is a test called the Turing test. So you know that if you are good on that, at the end you have to you pass some test to get the certificate. So for the computer also there is a certificate called the Turing test. So if the computer can pass the Turing test, we say that it has a general artificial intelligence. Once again, general artificial intelligence. So actually, whatever intelligence we are going to develop into the system, if they are really intelligent, then it should take it in its own way. So ultimately, our objective is to make the system in such a way so that it can pass the Turing test. And what is the Turing test? We will talk about later. So it is a special kind of test that actually tells you cannot differentiate that particular computer which are artificial intelligence and the human. If you don't, the computer becomes such that you are not able to differentiate, then we say that the system is actually going to your system that you made has actually passed the Turing test. With this, there is a very interesting thing that we for sure know that computer cannot do all the things. There is a limitation. Many things, many programs are such that, and one such program, you know that halting problem we cannot solve. So with the limited capability of the computers, we are thinking that we would be able to achieve this particular part. Okay, so all right. So with the limited capability, we actually want the computer. We want from the computer that it should be able to achieve the artificial intelligence. Okay, so we have talked about that intelligent task has the three categories: mundane task, formal task, and expert task. And there are few things actually written over here. This slide is an important slide. Okay, so it actually talks about that when we actually want to do the AI, What are the things? A few confusing things people talk about and try to understand that what they are. So try to understand this particular part. So let's assume that many things are there in the word that we wanted to do. In this thing, computer science is someone that is only related to the things related to the computer. We want to make the computer in some way. We want to do something into the computer science. In the computer science, we want to develop software. We want to develop good kind of hardware. We want to develop good kind of operating system. So out of multiple things are there. Out of them, few things are there which are actually associated with that how to develop intelligence into the computer. How to develop intelligence. So few things are there also which are actually not related to the intelligence. For example, given a list of 100 numbers, tell me that which is the largest number. This is a simple program that you can write and find out that which is the number. It doesn't require any intelligence. Okay. Okay. So we would come back to Turing test once again. Okay. So is it this part clear? In the computer science, we do many tasks. Out of them, some portion is actually dedicated to developing intelligence into the artificial intelligence into the computers. So that particular thing, whatever they are going to do, is called the AI. So in the computer science, there are AI and other things. Is it clear? Yes or no? Okay. For example, I've given an example that given the list of array, what is the summation? It doesn't require any intelligence, just a summation. Okay, for loop and finding out the same way, many things are possible. I want to send this information from this computer to that computer, doesn't require any thing. So those things are also there into computer science, but other things which are actually related to developing intelligence is called the whatever they do is called the artificial intelligence. So if you want to do now think about the just developing about the artificial intelligence. Okay. So artificial intelligence can be done using something which has solid mathematical background. You want to develop the AI. So there should be a solid mathematical background by doing this. So I just wanted to tell you, let's assume that there is I develop some system that is very good in guessing. I develop a system, I don't know how, but it is very good in guessing. So whatever question you are going to ask at the end, it is telling yes, 5, 10, 20. Let's assume that the system is like that. Okay. So such a system is correct because it has the intelligence. It is giving you the right answers. System is correct. Am I right or not? This system is also correct. Every time it is giving the right kind of how you are developing. I'm not talking about right now. I'm just talking about that you develop something so that it can search and give you the answer. It can guess and do something. So searching and guessing, okay, is many things, other method that you develop, they could also be a way to do the intelligence. Yes or no? Yes or no? Yes, they can also be a way to do the intelligence, but we are not concerned into those ways. We are concerning only to the mathematical way, things which have a solid mathematical background. We can also develop something that has a solid mathematical background that comes into the category of the machine learning. And here one more thing is this, that here we also say that I am not going to tell the system that what is right, what is wrong. System should by automatically do something to know that what is the correct for him. Okay. So I say that system should also try to do something so that it understand that what is good for him. Automated learning, automated way of learning. So all those methods are called the machine learning. What is machine learning? When there is a solid mathematical background, when you don't specifically specify that what the answer. So those categories are the solutions actually comes into the machine learning category. Clear? What is outside this? Developing intelligence. Developing intelligence without using these things, without machine learning is also possible. That is also comes into the area of artificial intelligence. All right, so into the machine learning domain, again, if you go dig down, you'll be finding out that there are multiple ways such as SVM, decision tree, and many other methods. So out of them, there is one method, one way of developing the intelligence is that using neural network. If you apply neural networks, so you try to develop the things which are actually similar to the human brain, then those category of the those category of the techniques are called the deep learning. What is deep learning? those categories of techniques which actually apply neural networks. What they apply? Neural networks. Those are the called deep learning. So it is clear to you that AI attempts to build intelligent entities which are actually intelligent, and our primary question is we want the computer to do the things which as present we think that the humans actually perform better. Human perform better. Any questions from this slide? Any questions from the slide? DL limits the neural network only. Yes, deep learning means neural networks. Everywhere techniques would be neural networks. Okay, everywhere techniques would be neural network. It is GAN. Okay, it is diffusion. It is unit or whatever kind of network it is. Okay, so all these models are going to use the neural network. Everywhere there will be neural network. Neurons. What is neural network? Very interesting question. So we will come back to you. It's a technique about this CNN. Okay, CNN is also there. Convolution neural network. So we will come back to this later. Okay. So what these techniques are, we'll come back to this later. What are the other streams in the AI apart from the ML? I told you that do some kind of search by searching the solutions, by exploring all the possibilities. This is again the intelligent way. Okay. If I ask you the question, try to come up with all the things. Okay. Searching, guess, some way of intelligent guessing, performing some different kind of operations, so different kind of sketches you can develop and give the intelligence answer. All those techniques comes into this particular category. Make sense? Where does data science fits in? Very good question, intelligent question. Where does data science fits in? So in the data science, actually, we are concerned with the data only. Whatever data is given inside, I look inside the data. Okay, and however, the line is very thick, many are thin, and people actually talk about that many of the time. They also talk about neural network and etc. things over there. So that becomes it becomes very difficult to draw a definitive line. But only issue is this, that mostly data science means thinking about the data, not thinking beyond the data. In the machine learning, we are intelligent, so we are actually thinking beyond the data. Okay, data mining is again the mining. If you want to do the mining, means you are going inside, you are mining inside and trying to find out what are things over there. In which situation we use the neural network. All these things we will discuss later when the time would come. So it would come. Okay, otherwise, where does ChatGPT fall in? ChatGPT is inside this deep learning. Okay, deep learning because it has a neural network architecture. So if you want to develop a artificial intelligence based system, so it's not a single thing that you have to develop. Multiple domains need to be there to actually develop the things. So in the AI, actually, definitely computer science and machine learning would be there. So in the computer science and machine learning is needed to develop the AI-based system. But from the biology, from the linguistics, again, you have to bring multiple things from there. For example, there is interesting session. Is big query of ELK based on ML or AI? So again, I'm telling all these things are actually part of AI only. Okay, ML means, as I discussed with you, that whenever you apply a query doesn't mean ML. Okay, so I think we can go forward. Okay, so later point of time when the things would be there, we can take more questions. Okay, so what I was telling that from the biology you should know, because neural network is all a sudden came from the biology only. Okay, it came. So linguistics, how the person speak, because ultimately if it is a AI based system, it should know that how the person is speaking, what these words mean. So linguistic biology is also needed to develop the AI. Psychology is very important. Okay, psychology means humans. You have to understand that how people interact. If you don't understand the psychology, you would be talking in the rude manner. So if you know the psychology, you know that these words are better as compared to the other words. So psychology is also needed. Economics is very much needed, because if you want to develop a system and you put all your energy into one place, that may not be good. Economics says that how you manage the different parts. Okay. So there is a question Vijay is asking that in what way the biology is mentioned. I told you, the neural network is actually all inspired. They are getting inspired with us into that particular way. And also, that liquid neural networks and other new concept that people are talking about. Every time when the person gets confused that how to solve the particular problem, they go to the God and try to see that how God has created. So God has created us. He knows that there is something called brain. From brain, they can take this thing. Every cell has every cell has a memory. So then they try to develop those kind of things, federated learning, that everything has a memory, everything has a model. How can we combine them? So ultimately, biology, and they are going to inspire us in a very influential way. Okay. Then mathematics and statistics, definitely it will be there, because statistics tell me that what is the most probable event. By this we can tell that I'm going to take this particular path, something like this. Mathematical background is definitely needed, because in the computer science is heavily dependent upon the mathematics. So all these things are related. And then comes a very important part called the psychology, philosophy. Sorry. Then comes a very important part, the philosophy. And let me tell you, philosophy is the most important part. Okay, philosophy is the most important part. What is philosophy? Philosophy is nothing, but from the air something is coming to me. Philosophy. As Newton was sitting below the tree and the apple falls on his head. I don't know whether it is true or false, but he thought that looks like that Earth was actually pulling this apple from pulling down to take it here. It's a philosophy. It came from nowhere. So philosophy comes from nowhere. You would be roaming around somewhere. Some thought, random thought comes to the mind. It's a philosophy, and then we wanted to apply this to somewhere to just see that how good it is. Okay. Okay. Then you try to verify. So somebody tells that I'm going to apply decision tree. Somebody going to tell that I'm going to apply CNN and our neural network, our SVM. So all these things, somebody has got some idea from the philosophy. So from the philosophy it comes, and then they are applied into the AI to make the system work. Any questions on that? So many things are required to do that. Okay. Uh, So as you know that when we were actually developing the things earlier, people were talking about that we should do some kind of formal reasoning and the theorem proving the thing, whichever things are correct, we should go in that particular way only. But at the later point of time, it has decided that it's not that easy. Okay. So for example, there is something called the Russell's paradox, that if I create a list of all list, okay, I have created a list that contains all the lists. Well, a list of students in this particular class, it is there. In this particular list, everything is there. List of flowers in the world, list of people who are good into the sports. All the lists are there. So in this list, where this list would also be there in this particular list or not, because this list does not existed when I started creating this particular list. So again, it is called the Russell's paradox. Similar kind of multiple things we can find out. So there is something called halting problem. I just told about this, that given a programming code, can the computer tell that this program will actually terminate or not? So we know that these things are difficult and cannot be solved by the computer. But even then, we want to develop the AI-based systems. Okay. Now I wanted to bring your attention to a very interesting topic. So a few minutes back we were talking about data, etc. So there is a very interesting term called data. There is something called information, and there is something called knowledge. So do you know the difference between these three? So I just for the sake of this particular class, I wanted to give you some definition. Please stick to that. Okay. So data is any raw fact. What is data? Data is any raw fact. Data is any raw fact. Anything is data. Okay. Anything is coming to you is data. But if you apply some kind of processing, what you apply? If you process something, so whatever the output is usually information. Is information. Try to understand this particular part. Information comes after processing. This processing could be give me the complete list. For example, data could be that how many students are there in my class. This is what the data. How many students are present in this particular class. This is called data. And what is the information? If I ask that how many people whose name is starting by A, your name starting by A is a data. Similarly, name starting by B is another data, another information. A big query distributed system or big data, elastic search engine, monitoring and visualization. Okay. I still wouldn't put them under AI, but the data science would be still closer. So I request you to please don't spend any parallel discussions over here. So we can stop and we can discuss with you. Okay, let's just finish this, then we can discuss. Okay, otherwise people get distracted. Okay, try to focus on this part. That's what I'm telling. That what is data? Data is anything that we have. Okay, data is anything that we have. So from this data, if you extract anything, for example, you apply how to find out this number of people whose name is A. You have to count from this, okay? You have to apply some kind of processing on this. After that, you get how many people's name is A, how many people's name is B. So this is going to give you what? This is going to give you information. This is the difference between information and data. Try to understand this particular part. Is this clear? Yes or no? Okay. Is it clear? Yes or no? Yes. So again, there is a question that what is the Russell paradox? So Russell paradox is this, that I am going to create a list which contain all the list. Okay. So at the time when I created this list was not there because I am creating this list. So in this list, whether this list would also be there or not, because this is also a list. Are you able to understand that? I am creating a list of all the list. So what is there? List of students, list of faculties, list of fruits, list of everything is there. In this list, whether this list is also there or not. Again, we don't know. Okay, we have to discuss about that. Okay, right now, I cannot tell that it is there or not. So there is Russell paradox, undecidable problem. So is it clear? So can I go ahead? Okay, so we are talking about that. What is data? From the data, we get what? We get information. Okay, we get information. So I can do one thing. This is a very important thing I'm telling you. One number of people starting by A, number of people by C, number of people by Z. I can store all this thing into another table. And when I store this thing, the information becomes what? Data. Information again become data. If I store somewhere, it becomes data. How can I can apply further processing on this, to find out what is the summation of all these numbers. So by this, if I get 300, means what? 300 students are there into this particular list. This is another way of finding out the same thing. But here, this information, when I got this 300, at that time, this 300 is information and this is the data. Do you see this particular part? When I applied, when I counted number of people with the A, number of people with the B, number of people with the Z, this information I have stored, it becomes data. And then I again applied another processing and find out that 300 people's summation is 300. So this is again called the information. And this becomes data. Okay, this becomes data. So data becomes, information becomes data as soon as I stored it into there. So you see the difference between data and information? This 300 was not inside this particular list. Different numbers were there. So information can be inside over here or not. It may be present or not. For example, if I ask that how many people, give me the name of people whose name is starting by A. So this is available into here. So information may be available inside the data or may not be available inside the data. For example, here, 300 is not available anywhere into this, but the summation is 300. So after applying the processing, we got this information. So this is the difference between the information and data. Information is stored is actually data. Data is created by the information. How can you create the data? Somebody is going to tell you something. Whenever he's going to tell you something, it's information. You are storing this. So from the information, you create the data. And from the data, you apply the processing to get the information. Then what is the knowledge? Then what is the knowledge? Knowledge is some generalization on the data. Knowledge is some generalization in the data. For example, we know that name of the people who are starting by A is actually greater than name of the people who is starting by Z. Am I right? Whatever student's name, if you have the list of the names, so it is actually like that. So this is the knowledge. So how come it comes? It comes from the different databases. Knowledge comes from a different databases, different kind of different databases, different list of from different universities. I have the list of all the students in a particular course. Okay, okay. So different kind of data I have, different kind of data I have, and in all that, if I see that this particular thing is actually okay, then I say that this is the knowledge I have. Please focus on this. It's a very critical point we are here. So who told you that this number of A is greater than number of Z? I don't know. It's coming from philosophy. I told you. Knowledge comes from where? Knowledge comes from philosophy. Who told you that this is number of A is greater than number of Z? Okay, you can verify on this all the databases that it is actually true. But from where it comes from philosophy. Sitting someday somewhere, thinking something looks like that it is going to happen. Verified on the data, it becomes 100. So knowledge and information, they are actually disconnected. Knowledge and data, they are actually disconnected. And it comes from where? It comes from philosophy. And this is the philosophy actually we wanted to discover. It doesn't come from a single databases, multiple databases. Okay, okay, multiple things from there it is coming. Make sense? So somebody is writing a very important thing, knowledge discovery through databases. So LKDD we wanted to do, there is some process, but there is a disconnect. How to connect them is a important part. Okay, so this is important thing. I think you must understand this particular part. And then I wanted to again tell you a very important concept that is called the rationality. I think this you should know today itself. There is something called the rationality. Okay, what is rationality? Rationality means being correct. Okay, based on the given data. So, I say that there was a room. There was a room. A was in with mobile phone. A came out of room without mobile phone. I'm sorry for my bad writing. I think you are. Is it fine? Should I write it with a better way? Is it fine? In the room, A was there with the mobile phone. A came out of the room without mobile phone. B came out of room. B came out of room. B came out of room. There is no mobile phone in room. There is no mobile phone in room. So can I say that B has stolen the mobile phone? Yes or no? Yes, yes, yes. How many people can tell? If somebody is telling no, wanted to talk to him, but right now I cannot. So you can tell that he has taken this room, likely. Okay. But if I put you more data, okay, no mobile phone. If I put more, C came out of room. Okay. C came out of room. If I put this, then can you still say that and there is no mobile phone in the room? If I put this information also, can you tell this the previous fact, yes or no? No, now you cannot tell this thing. Okay. So very important part. If I give you this much information, if I give you this much information, only this much information, your reasoning was correct. Yes, your reasoning was correct. But if I give you more data, then your reasoning was not correct. Okay, so based on the available data, if the system is giving the correct answer, whatever the possible answer is, then I say that system is actually rational. At that time, yes was rational. This time, no is rational. Okay, But it may be possible that in the human world, somebody is people are not. Let's assume that in some setting, people are not trustable. In that, anything is possible. Okay. So I don't trust on that particular thing. In the rational setting, what is going to happen? Based on the data that I have, based on the data I have, whatever is deducted, I say that this is what the answer is. My answer could be different also. Are you able to understand this particular part? My answer could be different also. Based on this, I can this should be the output, but I say instead of this, I say that reverse of this particular thing. I can say that. Don't no, that's not nobody is stopping me because I am human. So rationality means what? If the system is going to take the right decision based on his available fact, then I say the system is actually rational. Yes or no? Clear? What is rational system? Based on the given data, the system, a rational system based on the given data takes the decision. If the data is increased, maybe the decision can change to no. It is possible. But based on the available data, system takes the whatever the right decision is actually takes. Then the system is called the rational decision. So generally, if we are here, generally, if we go more towards human, if we go more towards the rationality, generally we think that maybe human could not be rational because let's assume that you like samosa. Okay, so if I give you the samosa, you'll be very happy. If I again give you the samosa, you'll be very happy. If I again give you the samosa, you'll be very happy. If I again give you the samosa, would you be happy? Should you be happy? You like the samosa very much, but if I give you morning, breakfast, lunch, dinner, every time if I give you samosa, would you be happy? No. Okay. So human can be something can be possible. So okay. So the system, however, the system, if it is a rational, it every time it will take happy. Okay. So sometimes we want to think in terms of the thought, we want to be rational. In terms of the behavior, we want to be rational. So all these things are dimensionals that we see. If the system is like this, then the system thinks like human. The system thinks like rational. System acts like human. System acts like rational. Something like this. There are four different categories we want to make. So any agent that we make actually works into this particular way that there is some environment. Okay, in this environment, the system is going to work. Whatever system we are going to make, yeah, you are going to your agent is going to work. So how your agent would work? It would sense that it was initially sense that what is over there. Okay, what is over there, and based on this, it is going to perform some action, and based on the action, it is going to get some rewards. Okay, I think this arrow is wrong. This should be here. I think it could be right also because what is the state system actually senses that what is the state. Based on this, it performs some action, and then based on this action, it gets a reward. And by this, it actually improves itself and makes itself better. Okay. So generally, people talk about two kind of AI: the strong AI and weak AI. In the strong AI system is actually having the AI thing. It is completely intelligent system. In the weak AI system, I'm not able to make the system completely equipped with the AI, but I do programming in such a way so that it looks like that it is intelligent. So it is called the weak AI. What is the difference between strong and weak AI? The strong AI is actually AI. Weak AI is actually doing something so that it actually looks intelligent. We were talking about the Turing test, and the idea was this: that there is someone who actually human interrogator. He wanted to find out that there are two possibilities: possibility of sitting human and possibility of sitting AI system. But AI system is such a good system. It is AI system. We make the AI system such a good system that it is very equal to the human. So he would not be able to tell that whether on the opposite side there is a human or machine. So such system is said to be pass the Turing test. If we make any AI system so that human interrogator cannot tell whether opposite side to me without seeing whether opposite side there is a human or AI, then we say that this particular system has actually passed the Turing test. So idea is just to you cannot reliably distinguish between he cannot reliably distinguish, then we say that this particular system has passed the Turing test. It's not very easy. Okay, it needs computer vision, it needs robotics, natural language processing, knowledge representation, automated reasoning, machine learning, many things it is required. Then only you'd be able to do that. Okay. Somebody is asking, AI would keep becoming more and more happy with respect to Samosa. Definitely. Yeah, because you like him. You're getting something like that. So there are multiple applications of AI. You know that there is no area where you cannot apply, be the spam filtering, credit card fraud detection, classification of DNA sequencing, stock market analysis, everything, everywhere you can apply this thing. And very recently, we have seen the great movement in our AI history when we have actually witnessed the Chat GPT. And everybody knows about that. Okay, Chat GPT is a system that actually deploys humans into the loop for regularization, and number of parameters that actually deploys is actually huge, and because of this the system is actually able to perform near human sentence formations. So reinforcement learning actually is an human. For the reinforcement learning, it is something like that, uh, try and error kind of system where the system is actually going to learn something by the help of the humans. Okay, so human is there to provide the feedback, and by this it can do the things. And you know that it is very good in terms of the sentence formation. However, it does hallucinations and does wrong things also. So gives a wrong answer also. So everything is possible, but in terms of the sentence formation, it is wonderful. One of the very great achievements of our time. Try to see this paper if possible, and that training large language model for demonstration of the human feedback. Try to read this particular paper. This is again a very interesting paper that is called from the same person, called the AlphaFold. Okay, and AlphaFold 2 is actually that given a DNA sequence, you want to find out that what is the 3D structure of that particular protein. Very interesting problem. If you do this thing by yourself, it may take generally it take more than 6 months or years of times to find out the correct kind of 3D structures. But with a very high accuracy, the system can give you within few hours that what is the 3D structure. And if you can do that, then definitely you will be able to do the drug discovery in a very fast way. That was actually you were doing earlier. Again, Deep Blue, you know that Deep Blue was able to beat the Gary Kasparov with there was a one win Gary Kasparov win. Then after that he loses and draw. So it is a very interesting piece of uh, thing that actually has been done. AlphaGo, you also know that Lee Sedol was thinking that he was a very big celebrated player. He was thinking that he would be able to beat the computer by 5-0, but computer was able to win 4 times. And even one time when the computer lost, it was very interesting story that why he lost. So there is a YouTube movie also. You can just try to see that how this particular system have performed with the Lee Sedol. He has just dashed this particular great player. So many things are happening. So you can also see that around 2015, okay, Waymo was a first car that it was able to provide somebody who was a soul blind person, and he was able to provide him the public ride from a open roads from place A to B in New York. This is again a very simple database that a German traffic is sign recognition database where accuracy is human has accuracy of 98.84%. So, for example, you can see that if traffic sign is there, there could be different lighting, etc. You may also find it difficult to see that what is written over there. But the computer has accuracy of 99.46% as compared to the human accuracy of 98%. So it is better than the humans. They can very fast map all these numbers. For example, all these numbers written. So finding out these numbers for a large amount of things becomes very difficult. But on the computer, they can do quickly. Image search, Baidu search engine. I have just posted this image to find out the similar images, and you can see that the images written by this search engine was this. All there was no single error. Everywhere there was elephant. Everywhere there was the same kind of background. Elephants were seeing front side only because my image was also front side. You can see that. So many things computers are able to understand. Describing the images, if there is an image, it can describe. If there are tissues, you can tell that where are the bad tissues and malignant and bad tissues, you can find out. So do the segmentation. So if you go to the doctors, they can just before going to the physician, they can ask you that what the problem you have, create a prescription for you before you enter to the system. So doctor just only have to just say that okay, yes or no, and things are done. Uh, so fill the captcha will, yeah, captcha has some limitations. Simple captchas are very easy to break, okay, but difficult, it becomes difficult when you improve something more, okay. So essentially, there are four different capabilities, such as reading and writing, looking at the things, in speaking and listening, integrating the knowledge. If you these integrate these four things, so you would be able to do 80% of the tasks that human actually does. And we have seen that in many of the places, many of the areas, computers are doing fairly well in the last 10 years. They have done huge development into this particular area. So we also know that as the time passes by, performance of human also improves. However, it improves very slowly. But the machine performance is going to be something like this. They are exponentially going to be better because better machines going to create better machines with a faster speed. They are something like this. So right now we are somewhere here, very near to the human capabilities, and we will be crossing very soon. In not more than 10 or 15 years, we will be able to, in next 10 or 15 years, we will be able to cross this particular limit. With the time, what happens now? If you develop something, so for example, in the industrial revolution, what happens is nobody has, for example, clothes, but after that, when you set up a factory, everybody start purchasing something, but after some time, it actually get stuck because requirements are going to be limited. But machine learning are going to be make better machines, so it is going to be better and better, and there is no stopping out of that. So we are going to go on to this particular category. If you are interested, you can just read this history, and I'm not going to that particular detail. So around 1943 that it started, and I'm not going to that particular detail. So if required, we can, if you're interested, we can have some time. Many places you can find out. So AI has been developed. So a lot of topics we have here. So intelligent agent, what are the, how to define the intelligent agent, what is the A star algorithm, semantic net, monotonic reasoning, rule-based system, deep learning, genetic algorithm, NLP processes. Many things are there into our syllabus. So this syllabus is available. You can just see about that. We'll be coming one by one to all these topics. In terms of the organizing our course, so it is as decided by the committee. We are going to conduct two quizzes. One is in the September and October. So it will be open for 10 days from 1st September, 1st October. Plus, and then assignment is from November 1, and these are 20% weightage. Quizzes are 5% weightage. They will be open for 10 days. You can solve at whatever time you wish. And then the mid semester test of 30% and in semester test of 40%. Dates are mentioned right here. Our goal is that we intend to provide the flavor of classical AI, build the fundamental to design the intelligent agents. This is our task, that you will be designing some intelligent agents and to give a gentle start to the machine learning. Course web page, as I mentioned, that here we have a course web page, and there is a standard book that we are going to follow, a modern approach by Stewart and Russell and Peter Nauran. This third edition, you can just purchase this book. Very important part, and that the solution must always be written independently whenever there is an assignment or quiz. If there is any similarity with the any artificial intelligence built or anything, you'll be getting 0 or negative marks. That depends upon the quiz. Please be very much cautious about this. Solution should be written always in the independent way. Okay, I know that you are a working professional. Finding part time will be difficult, but whatever time you have, I just wanted to see that how much you have learned. Once again, whatever method I have mentioned you to come to me in terms of the reachability, please follow this particular website. And if you need to follow, if you want to provide me a feedback or any question you want to ask, use this feedback link. Ask you to please participate in the pre-course survey, fill this particular form, so that I can tailor this course around your expectations. Thank you very much. This is all for my side. I have few minutes left, so I would take the questions.